All right, so last unit we focused on right triangle trig. This unit is going to be all about non-right triangles. Okay, so triangles where you don't have a right angle and how trigonometry works in them. Okay, so the first thing that we're going to look at is how can you find the area of one of these triangles? Now, I know that at some point in your life you have learned area equals 1/2 base times height, right? Where you would say, okay, well, here's where the height of my triangle is, and you would use that to find your area. You can totally do that, but if you have an angle that you know in your triangle, it's sometimes a lot easier to use a modified version of this formula. Okay, so if you know an angle and a couple of sides, it's a lot easier to use this modified trig formula than it is to try to figure out, okay, well, I have to calculate what the height of this thing is and then use that to fill in my formula, blah, 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 right? So let's just say I'm going to call this triangle ABC, just so that we have some letters to talk about, which means that since this is the side of the triangle across from A, we'll call that little a. This guy down here, my base, we'll call little b. And this guy over here will be little c, right? Because that's how you name sides of triangles. Okay, so what we can do here is when I look at this lovely little triangle, right, I'm going to focus in on this triangle right here. So triangle CB, and then where this altitude hits the base side. Okay, now what I want to do here is I am going to try to replace the h in this equation with something else using some trig. Okay, so the first thing that I'm going to do is I'm going to write a little equation here using this small triangle, because in this small triangle, I don't know how long this base side is, because remember, B is this whole side, so if I'm chopping off part of it, I don't have the whole thing. But I do know my opposite side, and I know my hypotenuse, right? So going off of angle C, I can use opposite hypotenuse, that's SOHCAHTOA sine. Okay, so I can say that the sine of angle C is opposite over hypotenuse. So that would be H over A in this case. All right, and since I'm trying to replace the H in this equation with a different H, I'm going to solve this equation for H, right, which just involves multiplying both sides by A to get these to cancel out, right? So then I'm going to have that A times the sine of angle C equals H. Okay, well then I can use that and say, okay, well this H and that H are the same, which leads me to my new equation, right, which would be area equals 1/2 times whatever the base is, times, and instead of writing H for height, I know that the height is the same thing as A times the sine of C. Okay, and the only thing that's vaguely annoying about this is it's not in alphabetical order. So I'm just going to rewrite this as A equals 1/2 AB sine C. Okay, so that is how you can calculate the area of this triangle using an angle instead of knowing all three sides. Okay, and then the one thing that I just want to point out to you is it's A, B, and then sine C. So A and B, and then the sine of the angle between them. Okay, so it doesn't matter what letters you use. I could have easily rearranged these letters, or I could have used angle A and said over here that the sine of angle A was H over C and solved that way. So it doesn't matter which letters you use. What does matter is that it always has to be two sides and the sine of the angle between them. Okay, so like I couldn't do A times B times the sine of B. That wouldn't work. It has to be two sides and the angle between them. All right, so let's look at a couple of examples in action. All right, we are not going to have to rewrite that equation the whole time. That's just kind of showing you where this is coming from. Okay, so let's take a look at this guy down here. So I want to find the area of this triangle. All right, so my formula for area equals 1/2, and then it's going to be the product of two sides and the sine of the angle between them. So it's 1/2 times 4 times 11 times the sine of the angle between them. Okay, and then I'm just going to flip over to my handy dandy calculator and calculate this. So 1/2 times 4 times 11 times the sine of 52 is 17.3. So the area of that triangle is 17.3. Okay, and that's so much easier, right? Imagine if you didn't know that, having to calculate the area of this triangle using 1/2 base times height. That would be a pain in the butt. So this is a lot easier. So this guy right here, my area It's the product of two sides. So it's 1/2 times the 7.8 times the 8 times the sine of the angle between them. So the sine of 110. Okay, and then I'm just going to throw that again in my calculator. So 1/2 times 7.8 times 8 times the sine of 110, which is 29.3. Voila. Oh, and I forgot my units, right? That's yards squared, or square yards. And then this guy up here would have been kilometers squared. All right, and then last one. So this guy down here, now this again, you got to be paying attention to which sides you're going to use, right? So it always needs to be the product of two sides and then the angle between them. So this is the angle that's been given to me. So I need to make sure I use the two sides on either side of it. So I'm going to use area equals 1/2 times 12 times 9.7 times the sine of 118. And again, I know I'm not using this 15 because it's not on either side of the angle. It has to be the two sides that make up the angle that you're going to multiply by the sine of the angle. All right, and then I'm going to throw this in my calculator. 1/2 times 12 times 9.7 times the sine of 118. So that works out to 51.4 miles squared, square miles. Okay, and that's it. All right, so it's really very, very easy to use. You just need to make sure that you remember this formula. And again, I can't stress this enough. Make sure that it's always the two sides and the sine of the angle between them.